Hello all. This video is mainly for those who are trying to learn PLC programming and all. I will show you how to do the basic programming in Delta's WPL software, which is a free software, and I think it is the best software to start to learn about PLC and basic programming stuffs and all. So let's jump into it directly. I will open a new file. I select SV2 and now we have created a file. Okay, and yeah, let's see the simple things first. First I have let's take that I have a push button and have to turn on an output. For that I have to type. You can also use these these functions given in the toolbar. You can also press the corresponding button on the keyboard to evaluate, like F1 for N normally open and F2 for NC contact. Since it time consuming and I'm also used to the keyboard, I will type here. I will type LD M0, and that's for an NO contact of M0, and I will type O Y0 to give us an output. Okay, now we'll simulate it. To simulate this one, you have to press the simulator button shown here, and you have to press that button, and if something comes up like this, you have to give the access. Now the access is given. Compile the program first and download the program. Now you have to download the program. Now go online. Now to run mode. Okay, so now it's in run mode. You can turn on the NO contact by right clicking and set on. Now the output is on, and in order to set that off, right click and set off. This is the simple this is a simple one, and I will okay, now let's see an AND logic. Okay, suppose I have two input M0 and M1, and only both of them get turns on, then my output is on. So in that case I will also add another memory bit LDM1. Okay, in this case only after both of the memory bit gets on, my output gets on. Okay, let's simulate it, and add on there's no necessity to every time you compile it and download it and run or stop. Since we have already done that, just simply press the simulator and go to direct online. You have to compile, you have to download, and you have to ask these questions, and you have to give corresponding answers. Okay, since both of them are off, my output is off. Either of them is on, my output is off, and both of my input gets on, my output is on. Okay, now this is our AND logic. Now we'll see an OR gate right now. In order to give space here, press Ctrl I and LDM1 for an NO contact of M1, and F1 to this line. Okay, so it is in parallel. Before it was in serial. Okay, I will directly go to the online. Yes. Okay, see, either of our input is off, output is off, and one of our input get on, output on. See, now it got on. Okay, next we'll see about the rising edge and falling edge buttons. Okay, for new beginners it will be very important to learn because it is very useful while in programming. Okay, what I will do, I will delete everything, and my condition is whenever an input gets on, my register should increment by 1. Okay, so let's take I will take an memory bit M0. You can take input, for example, like H0. H0 is also an input which is a hardware input button. Since I am using a simulator and I don't have any PLC right now, I will use M0, and I think it's good to use M0 like memory bits, instead of the input bits, and I feel this, but certainly not for everyone. Okay, see, I'll take an rising edge of M0. In order to get that button, I will type LDP M0, and this is our rising, and we have to increment a register D0, INC D0. Yeah, go online. Okay, yes. See, now you're online. Okay, whenever the memory bit gets on, off, on and off. So hope that's clear. And if suppose we have to count on increment, and also we have to count on the rising edge and also count on the falling edge, we can I will do another thing, LDF M0, and this is the falling edge trigger, INC D0. I'm sorry, I should choose another register. Okay, what this will do, and rising edge D0 will increment, and when the M0 falls to 0, it will increment D1. Okay, we'll simulate this. On, off, on, off. See, you can't notice the state of this button right now because it is in this interface. It is not properly shown. For convenient, we can use the monitor button if you want. If your program is very lengthy, and or if you choose to for any convenient method, you can use this edit monitor devices function. What you have to give is give the memory bit and the register you have to monitor. Since I'm rising edge and falling edge on M0, I will choose M0 here, and I will also choose D0 and D1. Okay, let's do this from the start. Okay, see, when our program, I think this is more useful. Okay, so you can see the both of them at the same time. Okay, 0 gets on, your D0 count up, and on the falling edge D1 count. See, it's counting up, and while on falling D1 counter. Same again. Okay, one more time. Okay, hope that was clear. And what if suppose I will quickly do one thing, like in this we have to turn on it and turn it off again and again. I will give a tiny bit of code, and you'll see it will do it automatically. Let's see, let's choose LDM M1000, which is an always on bit, normally open contact. This contact is on when the PLC is on the run mode. Okay, I will type ATMR K10, sorry, T0 K10, and I will output is M0. What this will do, that it is a always on bit while the PLC is in the run mode. And what this is it is a timer, and type timer, and it will count 1 second. Since the resolution of this counter is 100 milliseconds, so 100 into 10 means 1000 milliseconds, and 1000 milliseconds is 1 second. So after 1 second it will M0 will turn on, and now it will turn on. So we have to also reset this timer after the falling edge. Now choose LDI for NO contact, sorry, NC contact. Yeah, and basically that is it. This is why the timer is getting on and off instantly. That's why you can't notice any difference here. Okay, and we'll move on to next. What I have right next, set and reset. Okay, if you've done any courses and all, you must have known latching. LDM0 out M10. In order to make this M10 continuously on, you have to put M10 here, and put downside arrow. Okay, now it will get latched. M0 get on and on, off. The M10 is continuously on. To remove this and do this in a convenient way, in order to delete this downside arrow, you have to press Ctrl and D. Okay, now we'll set this M10, set M10, sorry, set M10, and only it get zippers. Okay, and when M1 get offs, my M10 should reset. Okay, see, it is necessary to give set and reset. If you set in one side, means you should have to reset it, otherwise the memory bit will get latched until you stop the program. It should be used in a pair. Set and reset should be in pair. Okay, we'll simulate it on okay, for convenience we'll monitor. Okay, see, we have M1, sorry, M0, M1 and M10. Okay, rising edge trigger. Okay, and it's off. And note that only M10 should only get off when M1 get off. It is a falling edge, so M10 only get off when M1 is falling from 0 to on to off state. Okay, so I will turn this on. The M10 should not be resetted. See, it is not resetted. You can turn it on or off either from this side or this side. It's your wish. And, okay, let's see whether it's getting off. M10 is getting off or not after a falling edge trigger. Okay, see, this is how LDF and LDP works, means rising edge and falling edge works. Okay, now we'll see an one push button on off logic. We'll exit the online mode. We'll delete it all. LDP, M0 out, M1, sorry, it is PLS M1, and that's a nothing to give. LDI M1, LD, oh sorry, LD M1 out, I0. Okay, this is a simple one push button on off logic. Let's see whether it's working or not. On, off, and the second press. Okay, this is a push button, so I'm pressing the push button right now. Now it is in the off state. Now I pressed, and it is in the hold position, and I switched it off. Okay, my output is on, and it is on the second press. Now I want to press the button. I pressed it, and it released. So it is working. This is a simple one push button on off logic, and there are many type of one push button on off logic. You can you done it by using a counter, and also by using NONC logic. You can find that on internet, and you can experiment yourself. I would recommend you that experiment yourself. And what are your next basic devices and their details. Okay, after experimenting and all, when you become a little bit confident, I will suggest you to check out the details about the devices present on the Delta devices, especially the Delta PLC. For that, you have to go to the help, PLC instruction and a special register reference. From this window, you can see there are all these things present here are the instructions available in a Delta environment in PLC. Okay, all this ABS, this is add function, alt function, and logic function, ASCII, which just convert X data into ASCII data, bmove, bit on, and see conditional jump, compare, and these are the special registers available in the Delta PLC, starting from D1000 and also M1000. M1000 is also special registers. See, all this you can from this single window you can learn, also experiment using it. This is very helpful while programming. You can quickly check something about an instruction and all. Okay, in order to get PLC informations, PLC basic devices information, what you have to do is type device range. Just type device and this will come. Go to this, and in this window you can see there are many type of PLCs available, like ES, EX, ES, SA, SV, SV2, SS2, SA2 and SE. And if you want to check something about that particular PLC means, you can simply click here. Like if you want to see some what are the present on SE means, you can simply press here. All this detail comes. Y, which is input, and output, how many input there can be. All this can be present here. See, this much amount of input can be possible, this much amount of output can be possible. Also the input, the memory can be run from here. How many memory bits are available in the PLC, how many of them are latched. Latched means the retentive memory types. These memory from starting from M5122 to M767 are latched. Okay, it won't get turn off after the power goes. This is what latched means. And the timer, see, like I said before, the resolution of the timer is 100 milliseconds, because see, it is in 100 milliseconds. So T0 to T126 has 100 millisecond resolution. If you want 1 millisecond timer means, see, it is available. 127 is available, 246 is available, which is a cumulative time. And same thing about the counter, and this is the count value, current value, that timer count value, or the preset value. And these are the register values. These are the general registers available, and these are the basic latched registers available, and this is the special registers available in the PLC. You can get a basic knowledge about the all PLCs available in Delta simply in the software itself. And the software is not that heavy. It might be around 100 MB or something, if I'm not wrong. And yeah, basically this is it. And you can search on internet for more details about the for more programming examples and all, and try doing examples here. And that's pretty much it. I wish you a happy learning. If you stuck on something, or if you're not getting what you're looking for, just don't give up. just scrap what you're doing, start new, and do that for 2-3 times, and you will get a new idea will come in your mind. Just never give up. And you can also reach me in the comments. I will respond to you for if you need any help. And thank you for watching, and happy learning.